Okay, so this is objective 11.2a. And don't get too excited, but I think this is the last lesson of the year. I looked at the final, and this is like the last question on the final. Therefore, I'm pretty sure this is it. Topic. Shh. Oh, wait. Half angle formulas. Notice I'm not calling them identities, but formulas. They're different than the half angle identities. However, they make a lot more sense than the identities. Make sure that you put these on your index card tonight because you do have a quiz tomorrow, which will require you to use them, and I will not let you look at your notes. Okay, you have two essential questions. Question number 1 is this: how do I determine in which quadrant theta over 2, theta cut in half, half angle, in which quadrant it lies? And question number 2, I'm trying to remember exactly how I worded the question. Give me 1 second. How do I accurately simplify fractions with radicals? Sometimes they'll be complex. Sometimes there'll be a radical underneath another radical. And this is not something that we do very often. And the calculator will not simplify. The calculator will approximate, because these problems that we're going to be working on today are quite a bit. Well, they're not simple to simplify. They're not simple to simplify. Okay, like that. Okay, so here we have the formulas, and I'm not going to derive them. I'm just going to provide them for you. The sine of angle theta, not theta, alpha, cut in half. So the sine of half theta, alpha. I'll get it right. Sine of half alpha. Here's how it goes. There's two options, positive or negative, and you will have to make the decision when to choose the positive or the negative. And then this is massive square root with a fraction under it. And we're going to, the formula goes like this: 1 minus the cosine of angle alpha all over 2. So when I want to find the sine of half alpha, I have to decide what quadrant is alpha cut in half lie. Where does it lie? So that I can choose, is my sine supposed to have a positive value or a negative value? And we know that based off of, remember this. So we will have to go back and rely on our knowledge of a smart trig class, or all students take calculus, whichever. You guys are a smart trig class, right? And not everybody takes calculus. All right. So there's that formula. Here's cosine of alpha cut in half, or half alpha. Looks like this: positive or negative, massive square root with a fraction. And it's almost the same, except it's 1 plus the cosine of alpha over 2. And then your tangent of alpha over 2 has 3 options. The first option I like because I don't really have to memorize it. I can just access it because I know tangent is sine over cosine. True? So I could say one formula could be the sine of alpha over 2 over the cosine of alpha over 2. So that's one option. And sometimes I like that one. It's easy to plug the values in for sine alpha over 2, cosine alpha over 2 real fast. Plug it in, simplify it, and I'm done. But sometimes these angles are really ugly values with square roots under square roots and complex fractions, and they're not fun. So other times I will choose this form of there's two more forms. The first one is 1 minus cosine alpha over sine alpha, which isn't too bad to use. And then the last one here is sine alpha over 1 plus cosine alpha, or theta, or x, whatever the angle is. So those are the three options for tangent alpha over 2. All right, something else I would like to point out, when you're choosing how do you determine in which quadrant theta over 2 lies, okay, a lot of times you'll be given a quadrant where angle theta lies before you cut the angle in half. So for example, if angle theta lies between 0 degrees and 90 degrees, and that's quadrant 1, right? So quadrant theta over 2, what I'm going to do is pick up my red pen to show you how I figure this out. What I do is I just cut theta in half, but if I cut theta in half, I also have to cut the angles in half. And so I get 0 degrees is less than theta over 2 is less than 45 degrees. And so in this case, theta was in quadrant 1, and theta's half angle was also in quadrant 1. Now, I'm going to give you some other options that are a little different. So another way to look at, or another problem to think about is, what if I said this, that theta was between 450 degrees and 540 degrees. So that's more than one revolution. And I think that might be quadrant 2. Let me think. 360, 450. Yeah, this is quadrant 2. But when we cut it in half, grab your red pen, cut everything in half. So theta over 2 would be between 225 degrees, which is in quadrant 3, less than theta over 2, less than 270 degrees. So in this case, theta was in quadrant 2, and theta's half angle was in quadrant 3. And one other option that I'd like to talk to you about is maybe when you have a negative rotation. So if I were to give you negative 180 degrees is less than theta is less than negative 90 degrees, well, what quadrant is that? Rotate backwards. Right? Here's negative 90. Here's negative 180. So where am I? That's quadrant 3. Truth? Quadrant 3. And then if I cut everything in half to find theta's half angle, that would be negative 90 less than theta over 2 less than negative 45. And I'm pretty sure that's in quadrant 4. And so you have to think, you have to place these angles, angle theta where it belongs, and then figure out where angle half theta is, because that's important so that when you're solving these problems for sine of theta over 2, cosine of theta over 2, that you know what quadrant you're in. Because sometimes sine is positive and sometimes it's negative, right? No? Are you with me? Okay. All right. So let's take a look at this problem. It says find the exact values. Clue, that says exact. No approximations of decimals. Okay. Exact values. Sine of half theta, cosine half theta, tangent half theta for the given values of theta. So here we have secant of theta is equal to 5/4. And theta is in quadrant 1. Right? So first we're going to cut theta in half to figure out where the half angle is. So we know that theta over 2 is also in quadrant 1. Okay, so I'm going to come over here, and here's what I need to think about. When I look back at my formulas, to find sine of theta over 2, look at my formulas, I need the cosine of theta before I cut it in half if I want to solve this problem. So over here, I'm going to draw a picture. I'm in quadrant 1, right? And this is secant of theta equals 5/4, and I need cosine of theta. Cosine of theta would just be the reciprocal of that, correct? So my adjacent is 4, my hypotenuse is 5. Please remember that adjacent is your x value, hypotenuse is your diagonal value, and then opposite is your vertical value. So adjacent is 4, hypotenuse is 5. Drop in your vertical line and put angle theta coming off the origin between adjacent and hypotenuse. What's the opposite? Yeah, this is a 3, 4, 5. And of course you can use the Pythagorean theorem to prove it to yourself. You have two sides of a right triangle. You can always find the third. So let's go ahead and find the sine of theta, because of all of my formulas, all the formulas I provided you, you need cosine of theta and sine of theta for the tangent. So sine of theta is 3/5. So I have a lot of information. So here's what I'm trying to find. I want the exact values of sine of theta over 2. So I'm going to come over here to angle theta, and you know what I'm going to do? I'm going to cut it in half. So this is theta over 2 right here. So I want to find the exact values. Okay? So here's the way I've worked out doing all of this work for these 3 problems. I'm going to grab my red pen. Sine of theta over 2 equals cosine of theta over 2 equals, and tangent of theta over 2 equals. And I work the problems. I just simplify them left to right horizontally so everything fits. And one other thing I need to mention is this. Since theta over 2 is in quadrant 1, and I know this, all values, all trig values are positive in quadrant 1. Truth? So that's really important when I'm going to choose which formula I'm going to use for my sine of theta over 2. Because remember what it is. It's either positive or negative square root. So since I'm in quadrant 1, I'm going to choose positive. So I'm going to choose positive, and I'm going to put that in a different color than everything else. So I'm going to plug in 1 minus, what's my cosine of theta? 4/5. All over 2. So I'm just plugging in the cosine, the value of cosine theta, which is 4/5, into my formula, and now I'm going to simplify this radical. So as I move forward, what's 1 minus 4/5? 1/5, right? Because it's 5/5 minus 4/5. True? which is 1/5 over 2. It is not, because 5/5 minus 4/5 is positive 1/5. Okay, so I have a complex fraction here. So you can either make them have the same denominator and simplify, or you can keep the fraction in the numerator, change this in multiplication, flip the denominator over. I think keep, change, flip would be good. So I'm just going to multiply times half, right? And work forward. So that's the square root of 1 over 10. So square root of 1/10. So how do we simplify that? The square root at the top and the bottom, you want me to do that separately? Because the numerator is 1. That's a perfect square, right? So that would simplify that. So that's one way to go about it, is to separate the square root of 1 from the square root of 10. It's true, those two things are equivalent, which is 1 over the square root of 10. And then we just rationalize the denominator. So I'll grab a different color to show that I'm doing that. By the way, let me do an arrow here. So I'm going to rationalize my denominator. I don't want a radical in my denominator because it's irrational. And we get the square root of 10 over 10. And that cannot be simplified. Therefore, the sine of theta over 2, its value is the square root of 10 over 10 exactly. Questions? Questions? Okay, then we're moving on to the cosine of theta over 2, which is also, in this case, positive. So our formula is the square root of 1 plus cosine theta over 2. So you know the only thing that's changing is the sign between the numerators, the numbers in the numerator. And so we simplify 1 plus 4/5, or 5/5 plus 4/5, 9/5 over 2. Then let's keep, change, flip. So 9/5 divided by 2 is the same as 9/5 times half. And so we get the square root of 9/10. Or can we simplify? Square root of 9 is over the square root of 10, which is not a perfect square root, or not a perfect square. So we kind of bypassed that middle step where we put the square root in the numerator and denominator, because you can see it, which is awesome. And we'll rationalize our denominator times square root of 10 over square root of 10. And we get our final solution, 3 square root of 10 over 10. Then we make sure we can't reduce 3/10, and we cannot. And therefore, here's what we know. The cosine of theta over 2 equals the exact value of 3 square root of 10 over 10. Now, last problem here. Do you have questions? Anybody? Is the color coding make sense? I hope. Okay. So tangent of theta over 2. We have 3 options for this, for finding the tangent of theta over 2's value. So I'm wondering how many of you want to go with the first option of sine of alpha over 2 over cosine of alpha over 2. You do? Yeah. Then let's do it. So we're going to go with this option. So I'm going to actually write down the option, the sine of theta over 2 over the cosine of theta over 2. So that's the option that we're going to go with. So I'm writing it down so we know which one to use. So let's plug it in. So sine of theta over 2 is the square root of 10 over 10. And cosine of theta over 2 is 3 square roots of 10 over 10. And while we created a complex fraction, notice their denominators are, so we can cancel them. And we get square root of 10 over 3 square roots of 10. You know, that's easy to simplify. Let me put a little 1 in front of the square root of 10 because I'm about to simplify that fraction. Final answer, 1/3. So that's a good way to go about solving that problem. I think maybe it's about the same amount of steps as doing the second option for tangent of alpha over 2, or the third option. You can pick any option you like. Sometimes one of those formulas is faster than the other. So there you have it. Questions about that? We good? All right, then let's move on to the next one, which isn't quite as clear. So here's what I have in this situation. We're still finding sine alpha over 2 or theta over 2, sine, cosine, tangent, all of that. So let's look at our given information. Tangent of theta, not cut in half, is 1. Shh. And theta is in quadrant 3. So I'm going to draw it real quick before I find the half angles. So what I know is tangent of theta equals 1 on all of the 45-degree reference angles. So in quadrant 3, I'm talking about this angle right here. So this is angle theta. And if my tangent is 1, then that means my cosine and my sine are the same. So negative square root of 2 over 2 and negative square root of 2 over 2. Because I'm in quadrant 3, my x and my y values have to be negative. And there I have my cosine of theta equals negative square root of 2 over 2. And my sine of theta equals negative square root of 2 over 2. Okay, so that's all happening in quadrant 3 based upon our first piece of information that the tangent of theta is equal to 1, and it's in quadrant 3. But we're not supposed to find that. We're supposed to find the sine of theta cut in half. So I'm going to pick up my pen, my red pen, and I'm going to cut this angle in half and cut everything else in half so we can figure out where theta over 2 is. So cutting 180 in half, we get 90 is less than theta over 2 is less than 135 degrees. So that means that this angle is somewhere between 90 and 135. So this angle right here is theta cut in half. This is quadrant 2, where sine is the only positive. Well, cosecant too, but we're not asked to find cosecant, right? So I know cosine, negative, tangent, negative. So when I get my answers and I'm finished with my problem, I want to make sure that my values actually are positive sine value, negative cosine, negative tangent. So let's start with the sine of theta over 2. And our formula is, we're choosing the positive square root and then we'll do 1 minus over 2. Let me wait, I gotta plug in a fraction here, so let me clean this up a little bit. So 1 minus over 2. Then I'm gonna plug in my cosine, which is a negative square root of 2 over 2. Okay, ready? I think yes, you are. Okay, So first I think I'll just go ahead and address my double negative. And then I will work forward. So this is a square root of 2 over 2 plus the square root of 2 over 2 all over 2. It's a lot of 2's. So are you ready to keep, change, flip, or do you want to combine your numerator into one fraction? Let's do it. Okay, I like the suggestion. So this would be 2 plus the square root of 2 over 2. That's your numerator. All over 2. So now we'll keep, change, flip times half. So we get the square root, not so massive anymore. 2 plus the square root of 2 over 4. And I'm wondering if you're catching on when my denominator's not a fraction, that I just multiplying this number times this number. 2 times 2 is 4. So if I have this, a over b over c, I could quickly just do a over b times c. Just a thought. Okay, so 4 is a perfect square, right? Yeah. So in my numerator, I have 2 plus the square root of 2, and the square root of 4 is 2. And my darlings, that's as far as we can go. We can't simplify that further. That is the exact value of the sine of theta over 2, where your denominator is rationalized. I did. Calm down. Okay, cosine. It's a term of endearment. Don't be weird. So cosine of theta over 2. In quadrant 2, cosine is negative. So we're going to choose the negative formula here. And the formula goes like this. 1, that's not a 1. Let me try that again. 1 plus cosine, which I'll plug in a second, over 2. Then I'm going to plug in my cosine of theta, which is blue pen. Negative square root of 2 over 2. Now I'm wondering if you can see how similar these two problems are. And I'm wondering if you could get to the end right away without doing all the intermediate steps. It's just going to be a negative square root of 2 minus square root of 2. Oh, that square root doesn't need to be that big. Let me squeeze it. Over 2. Because all that intermediate works the same, it's just there's a minus sign between the values instead of the plus sign. So, of course, you can work through it if you need to, but there's your exact value there. It's the same work, it's just a negative in between, or a minus in between the values instead of a plus. Last problem. Can you believe it? This is a momentous moment. Don't cry. Oh, were you crying? Were those tears of joy? Tears of joy. Okay. Listen. I will tell you that what I'm going to do right now, don't write, just watch. Is I'm going to go with the first option, sine of alpha over 2 over cosine alpha over 2, that formula, to show you why you might not want to choose that in this case. Okay, so look at your sine of alpha over 2 and your cosine of alpha over 2. You have, or theta over 2. You have the square root of 2 plus the square root of 2. You've got a radical underneath a radical. So in order to get rid of those radicals, you have to square, and then you have to square again. And the second time you square, you're squaring a binomial in its nature, which means you have to multiply 4 things and multiply conjugate. So just watch real quick how this happens. Don't have to write it down. So one option would be to go, okay, I'm going to do sine alpha. Was it theta over 2? Was the square root of 2 plus the square root of 2 over 2 all over negative square root of 2 minus the square root of 2 over 2. So at first it doesn't look bad because you can just cancel that, right? So you have 2 plus the square root of 2 over negative square root of 2 minus the square root of 2. But then I want to get rid of the squares, roots, so I square. So that gives me 2 plus the square root of 2 over 2 minus the square root of 2. And yes, this negative I squared. Negative times negative is positive. Now, in order to rationalize my denominator, I have to multiply. I want to get rid of the radical times 2 plus the square root of 2 and times 2 plus the square root of 2 in the numerator. So in the numerator, I have to do that, 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 and that. And in the denominator, I have to do that and that. It's a lot of things to remember. So it's a bit tedious. And so I suggest instead we don't try to find tangent when we have a square root underneath a square root. Do you know what I mean? Okay, so let's try something. Let's try the second option for tangent of theta over 2, which is this one. 1 minus, come on, cosine of theta over sine of theta. But remember that I'm using theta, not theta over 2. So this looks like this, 1 minus, and your cosine of theta is negative square root of 2 over 2. And your sine of theta is also negative square root of 2 over 2. See how this one's a little more simple? Okay, so it might be a better option. And I think in my numerator up here, I'll go ahead and change. And I'll rewrite as 2 over 2 plus the square root of 2 over 2. And if you recall, we've already pretty much solved that. Over negative square root of 2 over 2. I don't know why I did that in black pen. I just forgot to change my color back. So my numerator, I have 2 plus the square root of 2 over 2. And in my denominator, I have negative square root of 2 over 2. Simplify your complex fraction. And you get 2 plus the square root of 2. I meant to pick red. I did. I totally meant to pick red. And now all we have to do is rationalize our denominator, right? So what would I multiply by to clear the radical from the denominator? I don't have to do negative. I could do square root of 2 over 2, or I could do negative square root of 2 over negative square root of 2. You pick the one you want to do. I'm just going to do square root of 2 over square root of 2. And then I'm going to write my answer down here. So listen, you have to distribute that square root of 2 to both of those values in your numerator. So you get 2 square root of 2 plus square root of 2 times square root of 2 is 2 over negative 2. And you know what you can do with that. Show it some love. Can factor out a 2, right? So that would be 2 times the square root of 2 plus 1 over negative 2. And then cancel your 2's. That's a negative 1. Final answer, I'm going this way. Sorry. So square root of 2 plus 1 divided by negative 1 is negative square root of 2 minus 1. That was a lot of work. Follow the arrows. Follow the yellow brick road. And there it is. Now let's just verify that we didn't make any sign errors. Theta over 2 was in quadrant 2, right? Right? And so that means our sign was positive. In this case, our sign is positive. Our cosine, look here, is negative. And down here, our tangent is definitely negative. And you need to make sure that you do that. So on Canvas, there are 2 problems, 11.2a. You will do problem 6 and problem 8. 6 and 8, not 6 through 8. Okie doke. Did I make that and sign backwards? Is it a 3? No, it's not. Yeah, it's just those 2, 6 and 8. And there we go. Ooh, that was a long lesson.